In the previous unit, students learned different strategies for factoring polynomials. Prior to engaging in Unit 7, students will need to be able to multiply binomials, factor trinomials, and compare linear and exponential functions. In this unit, they will write quadratic functions using factored form, standard form, and vertex form. They will also graph these quadratic functions from the different forms. Let's take a look at the vertical alignment for representing quadratic functions in 6b to understand better what students will master in this unit and beyond. In Algebra 1, students will write equations of quadratic functions in vertex form when given the vertex and another point on the graph. They will then write the function in standard form. Progressing into Algebra 2, students will learn to write the equation of a parabola using attributes such as its vertex, focus, directrix, axis of symmetry, and direction of opening. Additionally, in Algebra 2, students will transform a quadratic function in standard form into vertex form in order to identify different attributes of the function. Let's explore the vertical alignment for identifying key attributes for quadratic functions in 7a to better understand what students will master in this unit and beyond. In Algebra 1, students will graph quadratic functions on the coordinate plane. They will then use the graph to identify key attributes, such as x and y intercepts and zeros. Progressing into Algebra 2, students will learn to write the equation of a parabola using attributes. Next, we will review the vertical alignment for identifying key attributes for quadratic functions in 7b to understand better what students should have already mastered to support this unit. Starting in 6th grade, students build their skills for Algebra 1 Standard 7b by determining if two expressions are equivalent. They used algebraic representations as well as concrete and pictorial models. In Algebra 1, students will describe the relationship between linear factors of quadratic expressions and the zeros of their associated quadratic functions. In Algebra 2, this is the basis for determining the linear factors of polynomial expressions of degrees 3 and 4. This includes factoring the sum and difference of two cubes and factoring by grouping. The vertical alignment for transforming functions in 7c can help you see what students should have already mastered to support this unit. Starting in 5th grade, students describe key attributes of the coordinate plane and how to graph ordered pairs in the first quadrant in mathematical and real-world problems. As students progress into 6th grade mathematics, the same skills are expanded to all 4 quadrants. When students next develop their graphing skills in 8th grade, they explain the effects of a translation, reflection, or rotation will have on a figure. It's important to remember that students often have a disconnect between what they learn in 8th grade and the transformation of functions. They think transformations only apply to geometric figures and rarely see the connection between the figures and functions. In Algebra 1, students will describe the effect on the parent function f of x equals x squared when transformed by modifying its algebraic representation using multipliers and other operations. In Algebra 2, this is the basis for describing the transformations of many different functions, such as cubic functions, cube root functions, radical functions, and rational functions like f of x equals 1 divided by x. Now, let's refer to the vertical alignment for using number and algebraic methods in 12b to understand better what students will need to master in this unit to prepare for Algebra 2. In Algebra 1, students will evaluate functions expressed in function notation, given one or more elements in their domains. Students will use this skill when analyzing the relationship between inverse functions in Algebra 2. As you move through this unit and find students who have gaps in their understanding of the prerequisite skills, consider using these resources available in the OpenStax Pre-Algebra book.